Now we're going to look at transformations of trig graphs. And transformations of trig graphs, so y equals sine x, cosine x, tangent of x, and so on, are similar to any other transformation. So when we had the basic absolute value function, we had these different types of transformations. We had vertical and horizontal stretches or shrinks, vertical or horizontal shifts, up, down, left, right, and then we had reflections in the x and y axis. So for example, if you start with what we call the parent function of absolute value of x, if you multiply the 3 outside of the absolute value, what you're doing is taking those y values for the absolute value of x and multiplying those by 3, which means that it stretches it vertically by a factor of 3. If you have the 3 inside with the x, now before you evaluate, you're going to multiply by 3. So that means that you're monkeying or changing the x value before you evaluate it. So that's why that's a horizontal, in this case shrink, because what's happening is you're getting to the y value 3 times faster, so it horizontally shrinks it by a factor of 1/3. And then you have the other vertical horizontal shifts and then reflections. So with the trig graphs, what we're going to look at is that those transformations are the same as other basic functions. So if we look from 0 to 2 pi, or 0 to 360 degrees, using different values of a, b, c, and d, we have these different transformations. So first, we just want to graph the basic sine function. So in there I have y equals sine of x, and if I press graph without changing any window or anything, in my standard window, this is what comes up. Now, if we want to go from 0 to 360 degrees, if I click the window button, right now I'm going from -10 to 10. So if I put the x min as 0 and x max is 360, let's see what happens. Now, the x scale, what I like to use for that in terms of degrees will be 90 degrees. Oops. Because that'll break it into the 4 different quadrants. You know, the y values, that's the height of the sine curve, which right now we're going to pretend like we don't know what it's going to be. So it'll go from -10 to +10. I'll just leave it at that, and let's see what happens. So here, when I change it to 0 to 360 degrees, that looks like my last EKG. So what happened? Well, in our window, I'm graphing from 0 to 360 degrees, but this is where you have to be very careful and notice the mode. I'm in radian mode. So what that's really doing is graphing 0 to 360 radians. And remember, one full cycle of the sine curve occurs in 360 degrees, or 2 pi radians, 6.28 as a decimal. So when I go from 0 to 360, I'm essentially going around that circle about 50 times, and I don't want to do that. So if I put my mode to degree mode, and then if I graph, now it'll show up as the sine curve better. Now notice how smushed it is, like how much space I'm wasting. So that's because the height of the sine curve, the highest y value on the circle is +1, and the lowest value is -1. So if I just do -2 to +2, so it all shows in there up nicely, now we can see we get the nice sine curve. So that's in degree mode. Now when we go from 0 to 2 pi, we want the mode to be radian mode. And this is why it's important to have just a basic understanding of what to expect when you graph these functions. Because a lot of students make the mistake and not think about what mode they're in. But that makes all the difference. You're going to get every answer wrong if you're in the wrong mode. So if I'm in radian mode, my window, I'll go from 0 to 2 pi. So x min is 0, x max, I'll put in 2 pi. And notice when I press 2 pi, then enter, it changes that to the decimal. And now the x scale, again, I just like to use pi over 2, because what that'll do, again, is divide me into the 4 different quadrants. Quadrants 1, 2, 3, and 4. So every tick mark you see will be pi over 2 radians. So now if I graph it, it's going to look the same as the other graph, but now I'm in the correct mode. And if I trace it, right there, it takes me to pi 4.1 e minus 10. Remember that scientific notation there, which means that there's a decimal point and then 9 zeros and then 4, 1. That's just because your calculator uses a program to try to trace it. But remember, when you're at pi, so if I press second pi, it takes me to 0. I'll just do a few of the graphs with you here just to give you an idea of what I'm talking about. So I'll graph 2 sine of x in the same window, and I'll make that graph thicker so we can see it come in. So sine of x is already there. Here's 2 sine of x. Notice that it's the same basic shape, but the highest it goes is 2 compared to 1, and negative 2 compared to negative 1. Notice that the zeros are still the same, because when you take the sine of 0 radians or 0 degrees, you still end up at 0 on the unit circle. So essentially what that 2 sine of x would do, it takes your sine values and multiplies them by 2. So when the value here was 1, multiply that by 2, you get 2. At 0, pi, and 2 pi, they were at 0, so 2 times 0 was still 0. If I graph sine of 2x, here's the sine of x again. Goes up to 1, down to negative 1. Sine of 2x, this is the thicker graph. And notice what that does. Now the sine curve runs through 2 cycles. And what's happening there is when you put a 2 in front of the x, now we're multiplying the angle by 2 before we evaluate it. So if x is, say, I'm just going to use degrees here because those are usually easier for people to understand. If x is 30 degrees, the sine of 30 was 1/2. But when I do sine of 2 times 30, that's now the sine of 60, which is 0.866. So what happens is we get to our values twice as fast. So we have 2 full cycles of the sine curve that show up with the sine of 2x. If I were to graph the sine of 3x, again, here's the sine of 1x, so there's 1 full cycle of the sine curve. And then here comes sine of 3x. Notice it'll complete 3 full cycles. The first one will end right here. The second one ends right here. And the third one at the end here. So that that b value is basically saying if you go from 0 to 2 pi radians, that tells you how many curves you're going to see. I shouldn't say curves, I should say how many cycles of the curve you're going to see. And then here, if I graph the sine of x plus 2, notice I put the plus 2 outside of the parentheses. So what that means is that the sine of x is evaluated first, and then you add 2 to the answer. So there's the original sine curve, so that's y equals sine of x, and then here comes the sine of x plus 2. Notice we just get the bottom part of the curve. That's because our window was only from -2 to 2. So let me change the window so it shows up. I'll put the x maximum to be 6. So there's the sine of x again, and then sine of x plus 2 shows up. So all that is, you see it's the same shape, it's just shifted up 2. So that's this will be your vertical shift up 2. And just make sure, you have to be careful with parentheses when you deal with these functions. Make sure that when your angle is just x, that you end the parentheses after the angle. And then the +2 will be a vertical shift up 2. So you can go through and do some of these other curves, and you'll see the transformations that happen with those. If we look at the bottom of the page, just to see what happens with the transformations, if you let x equal pi over 6, this was what I was mentioning before. If you do 2 sine of pi over 6, you calculate the sine of pi over 6 and then multiply that answer by 2. If you have sine of 2x, these are not going to be the same thing. The sine of 2x, you're going to multiply your angle, pi over 6, by 2, and then you evaluate it. And just to show you, if we were to graph both of these on the same axes, just to show that they're not equal to each other, I'm going to change the window back to the y maximum being a little bit smaller, just so they don't have too much wasted space. So if I graph that, there's 2 sine of x, and then here comes y equals sine of 2x. And we can see only at 0 do they end up being the same values when they hit 0. So it's 0, pi, and 2 pi. But that should get you to see that 2 sine of x and sine of 2x, these are not the same thing. So you cannot factor 2 out in front of sine of 2x. That's extremely important to understand. You cannot just bring a number out in front of the sine like it factors. That is not how it works. So that's a huge mistake to make. So if I show you the answers for each of these, so go through and plug in pi over 6 and see what you get for your answers, and I'll show you the answers. So pause the video. This is what I got for the answers. The few things I'll point out is notice that in the third one here, sine of x plus 2, there's no parentheses anywhere. So it's implied that plus 2 is not with the x. So when you enter that in your calculator, if you graphed it or did it all at once, make sure you evaluate sine of x and then add the 2 after you evaluate sine of pi over 6. And then in the next one, sine of x plus pi over 2, there are parentheses after that. So make sure that you include the pi over 2 in the angle. So I just went through and showed each step. So hopefully that makes some kind of sense.